And this the 21H. This one, it interrupts, like it tells the processor.
I'm asking,
one this line here, this block, we want to display this message.
There's what I can do. That offset R against the address of the other register and move it to the
So we are going to first put the address of R into the DX, the destination index. Then we put the 9H into the AH. This function, the 9H is the function for displaying. Now when we interrupt, this interrupt 21H calls the processor to run the function we put in the AH. So it will tell the computer to output. When you interrupt the processor, it will run this function. That means it will display this message. Then this next block here, we move the 1H. 1H is for input, getting input. So move the 1H into the AH. Then again we interrupt the 21H. That means it will tell the computer to listen for an input from the keyboard. Then we move now the result. When you press the keyboard, your data will go into the AH. Now we move the AH into the BL. When I register the data watch AL. That's how from keyboard AL. That means you move the data of the AL into the BL.
The input you're gonna go AL.
Yeah. Well, after interrupting, the input will go into the AL. Then from the AL you move it into the BL. That is the base base address register lower.
What we decide to move it in the BL, not in the CL.
No, this one's a random cut. But we have many registers. We never able to take away different. Digital demo BL. So we are not in the digital demo BL. Market has to kachitegeeza value ya R tugitadde mu BL. Then but now to this block here up to here now we want to display this H. We are moving H into the DX. Then we move the 9H for output. This is an output function. Move the output function into the AH, then we interrupt the processor for it to display. After that, now after displaying that message, now here again this block. Now we are capturing the input. The next what? Yeah. So now we move the 1H. This is an input function. We move the 1H into the AH and then we interrupt the processor. The 21H. Now, then now again it goes to the what? It will go to the AL. Right? The input goes to the AL. From the AL we move it into the CL. So now we put our H into the CL. Right? Now from here we are moving like pi into AL. Pi into L. You know, remember when like this command, it's like destination and source. So it's reverse. You're moving the quantity of the AL into the CL. Then here 1C. The moment the quantity of the pi, where pi is 3.14 into what? Into the AL now. The accumulator register lower. Then now we are multiplying. Remember, in multiplication, multiplication, when you write, When you write mal, let's say over 5, it will just multiply. No. Let's say, okay, like here. Let me just follow. Mu AL, tutademu pi. Now, when you multiply BL, this one will multiply the quantity A. It will be J. R abademu BL. Ne H alimuchi. CL. We multiply BL. This will multiply the quantity of the BL times pi. Because the malfunction, the mal command, multiply